obese fat, it becomes a pathological type of tissue. It becomes pathological. It secretes the wrong levels of the wrong hormones, very high levels of harmful hormones, and adiponectin, which is beneficial adipokine, its levels go down. Well, why is that so different? Why is obese fat different? Well, it's been programmed to be different. And the trouble is that even if you start losing weight, these cells remain programmed, signaling your body in a harmful way, ways that can cause you to get diabetes, cardiovascular disease, higher rates of cancer, because some of these adipokines signal more rapid cell growth rates. So we're trying to understand that reprogramming, because maybe we can figure out how to change it. Maybe you can even change it with diet and exercise, but we have no measure of it right now because we don't understand it well enough. If you isolate adipocytes and then you let them sit in the tube for an hour, a little while later it looks like butter is coating the edge of the tube, because they're all just breaking open and all the fat is sticking on this side of the tube, and it's just gross. You know, you have this gooey mess. So I really started thinking about ways to go get around these problems. And so almost everything in my lab has been, how can I do single cell types on these difficult cells that other people don't want to play with? And what I came up with was to take this whole antibody technology, things I started with as an undergraduate when I was 18 or 19, making antibodies, and try to extend that to trapping nuclei. So we try to think about, well, could we make antibodies to some of the really important cell type specific markers on the outside of these nuclei? So the grant that I just got, it's called CANA, Captured by Nuclear Antibody Technology. I've written them on the brain and the fat. The brain ones haven't been funded. The fat one is the one that just got funded. And we've already made our first antibody, but we're going to make hundreds of antibodies and then subcategorize them as to what types of nuclei they purify. So the nice thing about this technology is each antibody we get, I'm checking it against human cells and rat cells and pig cells and mouse cells, trying to show that we get a general antibody that anybody could use to capture any nucleus.